Okay. Hello, my name is Dru Doelling.
I'm Austin Neeley.
This is Team Meta, and we're going to do the last part, last lesson of the semester, lesson 13. To get this started.
So this one, no, let's just go to the question. So the question states, you wish to use the DNA sequencing as the same marker to determine the nucleotide. All right, so the sequence of the DNA nucleotide or molecule we're doing is TAG, primer, annealing, all that stuff. So pretty much the first part of one is to. Okay, there we go. There's A. All right, so I have to show you what my gel looks like. All right, my gel. It'll be just like that. It's really easy. You just kind of sort of with like GATC, but it's like the full DAC. So that's what we got for A. And let's do the rest of it. 13.
Why is that missing?
Dru Doelling, your laptop.
That's not good.
There we go. Perfect. All right, so B. Suppose I use E. coli DNA polymerase during sequencing reaction instead of attack polymerase. Well, if you did that, the DNA polymerase 1 will be denatured, so it would not function at all, and it wouldn't work at all, so the reaction will fail. C. Suppose I accidentally added E. coli DNA helicase into the reaction addition to the normal DNA sequencing reaction components. Well, nothing's going to happen because it's separated already through the heating process, and that's kind of the whole point of the helicase. It just still will not work. Or sorry, the reaction still will work. D. Suppose I added DTA-TP to one of the 4 test tubes as intended. However, I forgot to add the DTG-TP, DTTTP, and the DTC-TP. The other 3 tubes I was supposed to. Assume that the other components used for the sequencing are normal. So it'd fail because we still need the DTG-TP, DTTTP, and the DTC-TP. You don't know the sequences because of that, but it would still give us the T. It would work all the way up to the T value.
The DATP, right?
Yep. Perfect.
All right. For 2, during a typical PCR cycle, the synthesis step is done at 70 degrees Celsius, while the annealing step is done at 55 degrees Celsius. AMP is a common selectable marker that is found in many plasmid vectors, while the restriction endonuclease recognized and cleaved DNA molecules at cleanermic sites. Among the diagonal gel electrophoreses, is that how you pronounce it? Something like that. The DNA is placed in an electrical field. DNA migrates towards the positive electrode during electrophoresis. DDATP lacks a 2 OH group and a 3 OH group. Transformation is the term used to describe the process where bacteria take up DNA molecules from the environment. That's transformation. IPTG during blue-white screening is common. IPGT is commonly used to induce the expression of black operon, while X-gal is cleaved by B lactidase to turn E. coli cells. Okay, so number 3. So pretty much what we're doing is writing. So compare these 2 strands. You're interested in PCR to amplify the reach of double-strand DNA fragment E. coli and the sequence copied located between the sequence and the above below. So write a single DNA sequence that you use for the 2 primers used in the PCR experiment. Note that each primer will anneal to one sequence bold. So what we did is We did a 3 to 5. So what we have here, TC, GG, AG, TT, AAC, GT, GAC. Pretty much just from between the bolded section. So we got the answer. Double check. I lied. So it's from the bolded on the right side, I think. Is that how we did it?
Yeah, but it's like the reciprocal, so it's the anti-parallel.
So the anti-parallel, that's right. Okay, so the next one is 5 to 3. So we GA, G, CC, TT, C, A, C, T, C, A, G, T, C. Again, the same exact thing, reciprocal. B. So that this is the mathematical equations. We had an equation right here, trying to find degrees Celsius. So we did was so it gave us pretty much everything except for the GC and the N. So pretty much how many GCs there are, that's how much we put in. So it was 8 over 16. So 16 is the sequence, the total number of letters in the sequence. So you do like 8 divided by 6, and then since there's 16 total nucleotides, so we minus 675 divided by 16 will equal 35 degrees Celsius, 35.5 Celsius. And the next part will be exactly the same thing. So we have 9 instead of 8. It's be still 39.5 degrees Celsius. Each periodic cycle contains DNA synthesis step, where the sequence of the 2 newly synthesized strands of DT-CTP was actually included in the PCR experiment. So what we did was it 3 to 5, the CTAA, TTT, and then the 5 to 3, the GGG, AG, and ATG, C. So letter D. When we learn about DNA replication E. coli, we learn about DNA-A and DAM. What are these two proteins not included? Why are these two proteins not included in PCR experiment? Because DNA-A and DAM are supposed to limit the DNA replication. So we prevent from working on the experiment.
All right, perfect. Number 4. These ones are fun. All right, so number 4, we've got this wonderful chart right here. We've got all the base pairs that are here, and we've got the enzymes. So pretty much we're going to run it through our gel again, and I went ahead and I drew that for us. And I'm totally going to be mispronouncing all of these, but this will be good right here. Okay, so I've got the BAM high, they're my Igoride, my Hindu, and all the combinations of those. And this is the positive, so positive, my little plus 1. So all the base bars that are pretty close to the bottom, those are the smaller ones because they have a less surface area and they pull through the gel, the matrix. So I've got all these. Yeah, I just went through the chart and mapped it. It was that easy. So yeah. And then for B and C, this one is a little more difficult. And you just have to kind of play with the numbers and see what will work. So we went ahead and put 50, 150, 100, 100, 500. If we want to go back, the BAM high, we're doing something, not the BAM high, but those ones, like that'll be there twice because there's 3 of that we're given. Okay, and then C was pretty easy. You just went ahead and look at those cut, what would we have, and deduct those big ones that we have. Those are the given ones. Perfect. Number 5.
Awesome. So number 5, last problem. Okay, so pretty much the detailed steps how we use to generate the cDNA from the mature RNA and mRNA clone. So we look through the internet. What it says that we isolate the gene, I restrict your enzymes, the DNA ligase to create phospholipid bonds, take our new plasmid into the bacteria host before transformation. We will have code our genes, we will have our clone genes on the plasmid and then use the PCR to replicate okay. And then we take it out to get our cones. So those are basic steps, and that's pretty much about it. Hope this helps. Sorry.
There you guys go.
There you go. This is Team Meadow.
Signing out for this whole semester.
See ya.